Hi there, team, and welcome to another update on the situation we have in Iceland. I'm Geology Professor Shawn Willsey. Today is Wednesday, April 2nd, and we had quite the show yesterday on April 1st, and it was no April Fool's Day. It was the real deal. We had our long-awaited eruption, but there was a lot going on associated with that eruption. A lot of intense seismic activity, an eruption that was not as big as it was expected. Also an eruption that was not in the location that we expected it in. So let's see if we can make sense of this here with this brief little analysis that I'll share with you before I head off to classes this morning. First of all, we're looking at the area just north of Grindavik. You can see the abandoned greenhouse here, the protective berm, and our eruption took place on both sides of the berm. In fact, there's even a section of the fissure that cut through the berm, erupted through the berm. You can still see a little bit of the lava field just here east of the greenhouse where there's a little bit of outgassing going on here. This eruption is now, of course, over, but still cooling, and so we'll expect it to take many months, maybe years to completely cool, and there will continue to be gases coming out of that little pad right there. So there's that view there. We're also paying a bit of attention moving forward to the area near the highway between Reykjavik and the Keflavik airport near Vogar, because this became a very seismically active area yesterday, and it continues to some degree today. We'll look at the data here in a second, but there is some concern that moving forward, there could be an eruption here. Can't rule that out, and so webcams in this area will be very valuable moving forward. This is just another view looking past Stora Stokfelt off to the north and towards that highway. So that highway runs out here. Reykjavik sits over here, and the Keflavik airport's off the view to the left. So this webcam here could be quite valuable also moving forward. But let me show you a map exactly showing what took place yesterday. So the eruption was preceded by intense seismic activity, as we surmised it would. I think that lasted a few hours. I think the eruption began around 6:45. I'll have to check the numbers there. I didn't write that down, but it began in the morning in Iceland, on Iceland time. And this is the location of the vent that opened up. So you can see Grindavik here, the road that heads up towards the highway. The power plant and the Blue Lagoon are just north of this hill here. This is Thorper. And you can see the red lines indicating where the fissures were. Those were the active vents. And the purple there outlines the extent of the lava field from those vents. Now, a couple things to note here. One is that we had fissures both north of the protective berm that had been constructed, a few to the south, and even one here that basically was cutting right through the berm. And some of my video footage from my live stream yesterday on April 1st shows that with some of the webcams. So if you want to see some of that action from yesterday, I'd encourage you to go back and look at my April 1st live stream, and we were able to catch some of that. We flew drones over the area. We were able to see a lot of this taking place with various means. The other thing we can see here is this was a very low volume eruption. So you can see the extent of the lava here in purple. It's quite small. In fact, this was the smallest and shortest eruption of the 8 or so we've had on the Sunakur lineament since December 2023. So it was really, Grindavik again just dodged another bullet, because had this eruption been much larger in terms of volume, we would have had lava eventually leaving these fissures and flowing to the south, following the regional topography and moving right into town. But it was just very fortuitous that we had a very low volume eruption with lava flows of limited extent over this area. The most of the lava was to the north of the berms, and the berms did a good job of kind of keeping that lava at bay. And the smaller fissures that opened up here just lacked enough lava. It was a sluggish looking lava. I'll talk a little bit about what that might mean, why the consistency of the lava visually looked a little bit different from what we've seen with previous eruptions. But there's our map right there. And what we had yesterday, again, was intense seismic activity. I'll show you the earthquake data. The earthquake, the seismicity was just going berserk yesterday and still is continuing to some degree today. But we had intense seismic activity, mostly along a northeast-southwest trend. And then we had this small eruption. So in many ways, what happened yesterday, in thinking about this, it was a bit of a hybrid event in that it was both an intrusion and an extrusion or an eruption. So we had magma leave the storage zone underneath the power plant, inject itself over to the east into that magma dike, and then forcefully inject itself and lengthen that dike further to the northeast and the southwest. And by doing so, that generated a lot of the seismic activity we saw there. So intense seismic activity and a small eruption. So it was a lot like blending November 10th of 2023, albeit this was a smaller event in terms of total number of earthquakes and earthquake magnitude. So it was a JV version of the November 10th event, and it was a bit like the January 14th eruption, which was the small eruption we had here in Grindavik, including the small fissure that opened up and did destroy 3 homes here. So in my mind, it was a bit of a blend of those two events. It had the seismic activity and the intense earthquakes that we saw on November 10th of 2023, but it also had an eruption, but it was very small and but very close to town, which was the main hazard there, but it was actually pretty small in terms of its overall volume. So that's kind of my take on what happened yesterday, more or less in a nutshell. Let me take you over to Google Earth real quick here to show you exactly what happened. So we'll look at the earthquakes here in a second, but essentially what happened was our dike that formed November 10th, which was oriented somewhat like this. This is actually not perfect, but something like that. And that's maybe not even, this is something I put in quite a while ago. But the dike actually lengthened, and so we now have especially to the northeast, we now have a 20-kilometer long, about 12-mile long intrusion, a dike that extends from the coast just west of Grindavik all the way up here to the northeast, near the highway and east of the town of Vogar. This is based on where we saw the earthquake activity. It's not a straight line. There are some zigzags here. I tried to draw this as best I could based on the earthquake data. But this area in particular here, if you actually look closely here, you can see that the trend of my red line here, which is a approximation of where that magma dike is in the subsurface, if you look at the surface geology, you can see some structures that are subparallel to that are running in that northeast southwest orientation. And so it's very likely this magma is exploiting some of these pre-existing faults and fractures that run this way that are part of the plate boundary. And so we have a clear case here of the tectonic activity, the tectonic structures providing the conduits for this magma as it moves its way up to the surface. Once we get a little bit further south, it more or less parallels this volcanic lineament here, so it changes direction slightly, still northeast southwest, but a slight different trajectory. And then I kind of drew, it may be an offset segment, so it actually may be another segment here that oversteps over to this point here. But in this case, I decided to connect it with a line. That may or may not be true, but the earthquake activity we saw shows another sort of linear arrangement over here on the west side of Grindavik. So that's just an approximation. If you connect it all through and make that 20-kilometer long segment, it might look something like that. But it's following these pre-existing structures. It's following the cracks and the fractures and the faults that have been created over time by the tectonic movement here across this divergent plate boundary. Let's head back to the slides here, and let's start with the Met Office update. And so there's been a lot of information here from the Met Office. Let's maybe scroll back a little bit here. Let's get that a little bit bigger for you to see. And they did updates throughout the day yesterday, as you would expect. And so let's see, where do we want to start here? So this would be, initially in the morning, some of the seismic activity was picking up. I'm just going to kind of cruise through these so we don't have to read them all necessarily. And then at 9:45 was when the eruption began, local time. And that's where the fissure was initially. But then, of course, there was another fissure that opened up further to the north. And then fissures also propagated and opened up to the south. So we had some of those vents open up on either side of that there. So initially kind of short, but longer over time, and then they flew over it, and that fissure had extended from 500 meters up to 700 meters. I think at its maximum it was close to 1 kilometer long in terms of length. There's the seismicity of the morning of April 1st, more or less showing you, especially it was most vigorous and most active at that southwestern end and at that northeastern end. So that sort of indicates to me the magma was already in the system in between those 2 points, so there wasn't really the need to break rock, and magma was not really forcefully injecting itself into there. But these earthquakes at either end, I think, are a pretty good indicator that the magma was propagating and pushing in both those directions, breaking rock, generating those earthquakes, making space for itself, if you will, as it lengthened this intrusion overall in both directions. Yeah, and then the length of the eruption fissure got up to about 1,200 meters, a little over a kilometer by midday. And then by about 2:30, the activity was starting to die down. And even during my live stream, which went on for a few hours, we could see that, what we saw initially when we started streaming and what we saw later, things had changed a little bit. There's that same map I showed you there. This one shows some of the earthquakes at that northeast end. So here's the highway between Reykjavik and the Keflavik airport. Along the coast, there's the town of Vogar. This is the road that heads south to Grindavik. And you can see some of those earthquakes located here, and how intense those are in terms of, and how clustered those are, just sort of spatially. And you can also see here a lot of these thin lines here show some of the faults and fractures that run along there. So definitely following that same trend of structures that we see in that region. 5 o'clock update, activity continues to subside, but the seismic activity was still going on. So I'd say if you were ranking things, I know visually for us as people, the lava and the volcanic activity were the more appealing or maybe most arresting thing that we saw yesterday. But really, if you look at the data, the seismicity and the earthquakes by far were the main attraction in yesterday's event. And let me get to that here in a second. So this also shows, again, that the earthquake activity just to the west of Grindavik and the intense earthquake activity happening here is that lineament as that dike was lengthened further to the northeast. Of course, this is of concern because earthquakes up here in this area, if they are later accompanied by magma movement and an eruption in this area would bring the lava closer. It would head towards the coast and threaten this critical piece of infrastructure, this highway that connects the airport to the capital area. So not a lot of people living in this area. There is a town over here, which is of concern, but cutting off this highway with lava would be a big, that would be quite have quite the impact locally on the area. And then that's the last update there. 9:40 last night, no visible activity, but the seismic activity and the deformation continues there. They have here, according to model calculations, it was estimated that there was about 15 million cubic meters of magma that moved from the Svartsengi storage zone into that magma dike, into that subsurface dike. And then, let's see, but there was only a small portion of that actually that erupted at the surface. And I thought they had an estimate of that somewhere in here, but I might have scrolled past it, and I'll just kind of skip that for now. I'll leave a link to this and you can look through there. The point is that a lot of that magma stayed in storage. Very little of it actually erupted to the surface. And so we still have presumably a considerable amount of magma in the subsurface, but it also created more space for itself because it lengthened, it broke open rocks, it widened fractures in the rock, so it made more space for itself. And now the question is, of course, how much capacity does it have? Is there a lot of space for continual magma to move into this storage space, or is it pretty close to that threshold and is it pretty close to full? Those are some of the unresolved questions moving forward. So there's some of the Met Office updates. Let me show you the seismic data. This is just insane right here. So here's the Met Office. Here's their map of earthquake activity over the last 48 hours. So you can just see what was interesting about this and what I really don't have a strong answer for. I have an answer, but maybe it's not. It's not 100%. But you can see all the intense seismic activity on the Reykjanes Peninsula here. But apparently the seismicity, the movement of the magma in the subsurface produced enough regional unrest in terms of just stress in the crust, that it triggered all these earthquakes in the region, all the way up to the Snæfellsnes Peninsula, throughout the shallow ocean area here, offshore towards the Reykjanes Ridge, magnitude 3s and lower quakes. It was pretty incredible to see just the sheer numbers of earthquakes. The ones on the Reykjanes Peninsula were to be expected because that was, caused by the magma movement. But apparently, I guess the explanation I would offer at this point, and I'm not sure it's 100% accurate, so I'm willing to entertain others, is that this was of such a magnitude, just the sheer stress that was transmitted through the crust because of this magma intrusion, triggered earthquakes even several, 100 or more kilometers away in some of these more far-flung regional areas here. Just pretty incredible. And then this is equally as compelling here. As you can see, going into Monday and into Tuesday, this is what we've been seeing over the last several weeks, is earthquakes, but not a lot of earthquakes, but they were steadily increasing on the Reykjanes Peninsula. And then you can see, like right at, I think it was 6:45 in the morning on Tuesday, is when the seismicity just picks up in earnest here, and we get not only tons of earthquakes, lots of earthquakes, high frequency, but higher magnitudes. You can see the magnitudes ramping up well over to 3. Some of those eventually go over 4 in magnitude, and that just really persists. The eruption, of course, begins around 9:45, so about 3 hours later, somewhere in here. But you can still see the seismicity quite elevated, even though the eruption had begun. But you can see, looking at the data up through this moment in time today on Wednesday, that even though seismicity remains quite elevated and high, there is a definite decrease here in not just the frequency of earthquakes, but the overall magnitudes of the earthquakes too, right? If you put a trend line on that, that's clearly trending down. We did have one today over 3, but yesterday, how many were over 3? Gosh, there were dozens that were actually over magnitude 3 yesterday. So a decrease in magnitude, a decrease in frequency, and we expect that would continue. Not that that's a for sure thing, but that might continue to drop off and die down over the next couple of days. But of course, we'll watch this closely. That would be something to really pay attention to. But that's really impressive there. Other way to look at the earthquakes is with this Vafri site that we often use. It's going to cooperate. Let's try and refresh that. And this was a bit overwhelming yesterday, just because they graphically show the circles they use for the earthquakes are just so large. So this is the last 24 hours. And again, it's a bit overwhelming. So we'll go through a couple ways to kind of parse this out and make this look a little bit different. So yeah, you can't make heads or tails of it other than seeing that, like, holy cow, there's a lot of earthquakes. You can see some in there, 4.3, 4.2. There's quite 4. There's a 4.1. And then, some of these larger quakes that are just regionally not even, connected or very close to the Reykjanes Peninsula, that were seemingly triggered by this major magmatic intrusion. So one way we could go about this is we could weed out the small quakes, just look at the ones over magnitude 2 yesterday. That still leaves kind of a cluttered picture, so we could go to just magnitude 3 and above. That's a little more clear. Again, you can see some of those bigger quakes on the Reykjanes Peninsula, both at the tip and the ones here. But again, to be clear, none of these other earthquakes are indicative of magma movement in those areas. These are likely quakes that have been triggered by stress changes in the crust because of what was taking place around this magma intrusion. So the magma intrusion is generating the earthquakes, but that doesn't mean that magma is at those locations where we see some of those other earthquakes. So the other way to look at this is to maybe, and this is being kind of slow here, is to parse this down to maybe the last 12 hours. So just looking at, what's taken place over the last 12 hours. There's been some earthquakes here, but let's add in the ones around the Reykjanes area or the Svartsengi area. And you can see quite a bit there. We can use the fun little map function, or wait, sorry, area function, that's what it was, to sort of focus in on Svartsengi area. This is being a little slow, but there's a view there. And that's a nice view there. This is the last 12 hours or so, and that nicely sort of delineates more or less that trend there. You can see, though, that the bulk of the seismic activity is happening up here at the northeast end of this magma intrusion. So if we go, what's happening even more recently, let's just look at maybe the last 4 hours. Yeah, there's still earthquakes happening there, but again, they're actually, most of these are quite small. So, you know, magnitude 2s, there's only been one. So it's definitely a step down from what we were seeing yesterday, but still worth watching and you know, continuing to monitor to see how that trend looks in the long term. So I'll put a link to this as well. Another way to look at the earthquakes from the Fire in Iceland site is this fun little 3D model. So this is earthquakes over the past 48 hours. So here we have, let me get you oriented here. Here's the Blue Lagoon. Grindavik is actually, can't see it very well because it's down here. It's right there, that black dot there. But when I tip it back to vertical, so Grindavik is right here. And what you can see here quite clearly, and this is quite interesting to me, but almost no earthquakes in the middle segment along the magma dike. Basically, where we thought we would see the eruption between Slingerfell and Stora Stokfelt, we didn't even get hardly any earthquakes there. Instead, the magma pushed and propagated to the southwest, generating a lot of earthquakes, and to the northeast, doing the same thing. And so that's where we see the bulk of the earthquakes. If we sort of tip that into profile view and rotate it, we can actually make out that dike. You can start to see the more sort of tabular appearance as we get those things kind of lined up. There we're kind of looking at it end on from the northeast to the southwest there. And so again, a lot of these are quite deep. We didn't see these quakes really start to shallow much. You can see the bulk of those quakes around 4 to 7 or so kilometers in depth. So they're still quite well below the surface. So super interesting from the standpoint of the seismicity. Let's look also at the GPS data and see what we had going on with the GPS data. I need to get this wrapped up here. I got class in about 25 minutes. So Svartsengi station is the one we've been looking at the most. And let me get my little face out of the way a little bit here for you. So here's our steady uplift, the rise of the GPS station over the past 3 months or so. And then we get into April. April 1st is right about here. And you can see we've got 3 data points that have dropped down. So we've had some deflation. Now, this isn't necessarily all because magma erupted to the surface. Remember that you've taken some of the magma from the shallow storage zone underneath the power plant, and you've transported a large amount of that magma eastward to fill and extend this dike, this structure that's storing magma as well. And that's what actually transports the magma up to the surface. So it's not as clear cut as saying, well, we can look at the amount of elevation drop here and estimate how much erupted at the surface from that, because you've actually moved the magma from one location to the other in the subsurface. Let's go back and try. This is the 8-hour plot. Let's grab the 4-hour plot as well and see. And let's just use the Svartsengi one again. Yeah, so it just gives us more data points here. And it's too early to tell, right? All we can see is we've had an eruption. We've moved magma from one area in the subsurface to another, including a bit of that magma to the surface. And so watching this over the next few days and weeks is going to be critical, because what we want to see long term is we want to see, does inflation resume? Do these dots start to turn and swing back up? If we start to see a steady uptick or upward trend in this data, that would indicate that more magma is intruding into the storage zone. It's rising, feeding into the storage zone. There's an influx of magma from deep, and that would suggest we're also going to see some other event in the weeks and months ahead. Maybe another big intrusion, maybe an eruption, maybe like we saw yesterday, a bit of both. So the INSAR data will be the thing to watch long term over the next few days and weeks. what else do I have here? A couple news events or news stories that I picked up. And most of these came from Amanda Jo, so thanks as always to her for sending these to me. So here's one of their geophysicists in Iceland believes that if a land uplift or if there's inflation that resumes, there will be a period of uncertainty. And I couldn't agree more that we are in a definite period of uncertainty. So it's impossible to predict what will happen. Yeah, and so he's mentioning and acknowledging all the variables in the system, and that now we're sort of in a new phase, a new regime. All the things we learned about this system over the past year, where it had established a clear conduit. If you remember the earthquake patterns for many of these previous eruptions, the earthquakes right before the eruptions were clustered in a very narrow spot, and that's where the vent was. What we saw yesterday was the earthquakes being distant from where the actual eruption occurred because the magma was mainly an intrusion event. So even though you saw some of the red glowy stuff at the surface, the main action was happening yesterday underground with the earthquakes and with the intrusion. From another news site there, this is Benedict Olfigsen from the Met Office. He says here, at least yesterday, it's unlikely that another eruption will begin at the northern end of the magma chamber. I think that's from yesterday's eruption. I don't think he's saying that necessarily long term. Didn't really provide any data that I saw with that. Just didn't think, just probably looking at how deep those quakes were, and because we didn't see those quakes shallowing up towards the surface, that it didn't look like that magma was moving up towards the surface. If the magma can move easier, if it's easier for the magma to propagate laterally in the subsurface, then it will continue to do so. There's nothing that makes the magma want to rise unless it has a lot of gas in it, and that will increase its buoyancy, or if there's an easier pathway structurally to get that magma up to the surface. So intrusions are actually more common than eruptions. It's just we don't often see them and acknowledge them, so they go less noticed by humans for the most part. And let's see, what do I have here? There was some cracks that showed up in Grindavik and some of the roadways and such with all the stress changes and the earthquakes. That's not uncommon. I wouldn't be surprised if Vogar and some of the other roadways closer to where those bigger quakes occurred, if there was maybe some cracks and some minor damage into some of those roadways as well. And then finally, what do I have here? This is an article that just talks about the length of that intrusion. So the seismic activity delineates that it's about 20 kilometers long, which is really impressive. Yeah, so that's what I have for you today. Moving forward, what are the things to watch? I think I'm going to be keeping an eye on the seismicity, at least in the short term, for the next few days, and really even longer, but keeping a closer eye, I suppose, on it over the next few days to see how the seismicity plays out in this area. Do the earthquakes continue to die down? Do they pick up? So I think watching the seismicity will be important. I think watching the GPS over the next, like I mentioned, long term, this will be important. We really want to see what happens to this inflationary data. Does this actually give us an inflationary trend? Does this start flatlining? If we saw this flatline over time, that would seem to indicate that we have no continual magma recharging the system, moving in from deep, and that might be the end of this eruptive period in this area. I don't think that'll happen. I think we're going to continue to see magma moving up, probably at a slower rate than we saw previously. But my hunch would be, based on what we've seen previously, that we're gonna see that inflationary trend. It's just maybe going to take a week or so to actually, see a clear trend in that data. So I would watch for that. So things are different now. We have this event has undoubtedly changed the plumbing system, the pathways that the magma moves through. And I think that makes it very different moving forward. If we were to have another eruption, I think all bets are off in terms of like, where would it erupt? We had established this little area here based on prior eruptions as the most likely place for the next eruptions, because there was a clear pathway from the storage zone up to the surface somewhere in here. That's where we saw 7 of those 8 eruptions take place. I think now, who knows if those conduits have been breached, blocked off, widened, perhaps, and it's anyone's guess as to where the next eruption would take place. And that's why watching especially the seismicity and the earthquake data will be key moving forward. But predicting where that vent's going to open up is less sure now than maybe it's ever been. Well, I guess since November, late November, December of 2023. And this is important, of course, because where the vent opens up for each eruption plays a huge role in determining the hazards, right? Vents closer to Grindavik can be quite catastrophic. Vents that are in the central area often threaten the Blue Lagoon and the power plant more directly. And now we have this third threat of vents up here to the northeast, which could be a threat to both Vogar and the highway here, this important critical piece of infrastructure. So we'll have to see moving forward. They did collect samples of that lava yesterday. It looked kind of sluggish. It looked like it wasn't nearly as robust and hot and runny as some of the other eruptions we've seen. That might suggest that what we saw erupt yesterday was residual magma from previous eruptions that stayed in the subsurface that was just forced outwards by the pressure of the new magma that came in. And the geochemistry will be able to tell us if that was the case or not. So we'll have to look at some of those analyses moving forward. So that's all I have for you today, but I'll be back with you when there's more to talk about. Thank you for your support of the channel. Thanks for learning along with me, and we'll see you next time. Take care, friends.